Haya, we will begin. If there is anyone who is going to join us atatupata tukiendelea. Now, today we are going to be talking about metal forming. Last time tulikuwa tumefika metal extraction processes na nikawaambia mtengeneze presentations. Sijui kama mnatengeneza ama mko nyumbani hata muongelesheani. So nataka mfanye hivi ili muweze ku revise hata mkiwa mahali ambapo mko. So next class tutaanza na hizo presentations next week. So make sure you prepare kama hii ambayo na present. I hope you can see my screen kwa wale ambao wameingia sahi. I'm sharing my presentation, so if you cannot see it, please let me know. Mnaona? Okay. Now we'll start with metal forming. So metal forming is a process ambayo we deform materials ama metals. Plastic deformation. When I say plastic deformation, I mean permanent deformation. When you take a material, a metal, and you deform it internally mpaka ika change structure, that is what we call plastic deformation. So metal forming is that process of plastically deforming a material, and we can do this using tools kama dies na punches, and we will look at these tools in the next topic, workshop tools. But we will use tools, mfano dies and punches, to perform these processes. And these tools will be different kulingana na the process that you want to perform. Are we together? Now, we will mention these processes one by one, a few of them. These processes can be divided majorly into two categories. We can talk about bulk deformation, or we can talk about sheet metal working. Now, bulk deformation is those processes ambazo zinahitaji uzito. When you're working with heavy machinery, when you're working with huge metals, kama unataka kukata chuma ambayo ni 1000 kilograms, we declassify that process under bulk deformation. If I'm just cutting mabati, that is sheet metal working. Now, under the bulk deformation, we have other processes kama rolling processes, forging processes, extrusion, wire drawing, and under sheet metal working, kuna bending, stretching, deep drawing, shearing process. We'll mention these processes in a few, and then I will also be playing videos ili tuwe na tuwe na a visual idea of how these processes are done in a workshop ama kule kwa industry. Now let us start with rolling process. A very good example of rolling ni ule mtu ambaye anatengeneza juice ya miwa. I'm sure you have come across them katika town. Kuna ile machine ambayo anatumia ni a rolling machine. It has cylindrical dies ama cylindrical rollers ambazo zinavuta hiyo miwa katikati yake. And then those rollers compress. They will compress that sugarcane and the juice will be extracted. And that is the basic idea of rolling hata kwa industry. You will have rotating dies that are cylindrical in nature, and you will have a metal being passed through those rollers inavutwa, and that workpiece or that metal will be compressed. Na sana inatoka kama a sheet metal, inatoka kama babati, imekuwa reduced in size. And that is the rolling process. Let me play a small video so that we can see, we can have an idea of how it looks like. I don't know if you can see the video. Mnaiona? Anyone, please let me know if you can see the video. Mnaona video ama muoni? Si mtu aseme tu kama anaona. Mnaona video kweli? Okay. I think we have gotten an idea of how rolling is done. Ukitumia chuma. If you're going to roll a piece of metal, you just pass it through rotating rolls ama rotating dies, and then it will be compressed. Kama pia I'm suggesting that if you're in a place ama mahali ambapo unaweza andika and write some things down. Be noting some of these processes down. Now forging. Forging I'm sure you've seen this. Watu blacksmiths, watu ambao wanagonga chuma huko kwa mtaa. They will take a piece of metal and deform it by striking it. And we can do this also in a workshop by placing a piece of metal between two dies. Mfano, if I want to make a cross, mfano, msalaba, I will take a piece of metal and I will place it in between two dies that have a cross shape, katikati ya hizo dies, and then I will apply a force onto those dies, and that shape itakuwa imprinted, itatokea katika my piece of metal ama my workpiece. So when you apply force on a die and you compress a piece of metal, this is known as forging. Now there are very many types of forging, but this is just a very simple explanation of what forging is. Kuna ile ya blacksmith ambaye anachukua chuma anaekelea katika anvil ama a place kisha nagonga. That is still forging. When you are applying force on a piece of metal to change its shape ama to deform it, that is forging. Now another process ni extrusion. We have a die hapa, and I want to push this workpiece, my metal, through that die, the cross-sectional area of that die. What I will do is I will place that workpiece within that die, and then I will apply a force through a ram, hydraulics, nitatumia hydraulic power, and I will push that workpiece, some of that metal, through that cross-sectional area ya hiyo die. So sana we do this if you want to reduce the size of the workpiece, or if I want to change the shape of my metal. If I have a cylindrical shape and I want to change it into a square shape, all I will do is I will push my workpiece through a cross-sectional area that is rectangular ama square. Ukienda ununue chuma alafu ukapata ni cylindrical and you do not want to buy another one, utapelekea tu fundi ataisukuma, utaweka kwa machine, kisha hiyo chuma itasukumwa katika die ambayo iko na a rectangular shape, and you will get a final product ambayo iko rectangular. So you push or you compress a workpiece through a die that has a cross-sectional area that is either smaller or has a different shape than the actual workpiece. So let me play a small video so that you can see how it looks like when it is done in a workpiece or when it is done in the industry. I think we have seen how it is done. Unaweka workpiece ama chuma yako katika hiyo die, kisha unaisukuma. You apply a force, and then we will assume that shape of that cross-sectional area hapa ya hiyo die. So kama unataka ku reduce size itapungua. Kama unataka chuma tatu, unatengeneza die ambayo iko na 3 cross-sectional areas tatu. Once you push that metal, a force will be applied, and that workpiece will deform to take that shape of that die. Now we have a similar process known as wire or rod drawing. It is very similar to extrusion. The only difference is you're not pushing the workpiece ama the metal, you are pulling it. You will apply a force and then you will pull your workpiece through that die and it will assume the same cross-sectional area. So extrusion na wire drawing is similar, lakini tofauti ni kwamba kwa extrusion you are pushing the workpiece ama the metal. Katika wire drawing you are pulling it. Are we together? Now those are the categories of bulk deformation, zile ambazo zinatumia a lot of force or you are using large ama huge metals. Now for sheet metal working we have bending. Kama umepatiwa kazi na unatumwambia utengeneze fridge na umepatiwa a square, umepatiwa tu chuma, you have to learn how you have to make corners and you use a bending press to make those corners. So bending it is ideally you're just making a corner or an angle katika your metal, and what you will require is a force, a die ama a punch ama a ram. You will place your work metal ama your metal on top of a die, kisha you will push, you will apply a force on a die ama a punch onto that metal, and that metal will take the shape and that angle of that die. So if my die is 20 degrees itachukua 20 degrees, if my die is 90 itachukua 90, if it is 45 itachukua 45. But the shape, the angle of that die will determine how much we bend that metal. Now the force that will be applied katika die, during the bending process will depend on this angle. If my angle is bigger, kama an angle of 60, I will use less force as compared to trying to bend a piece of metal 20 degrees. Nitaitumia less force kubend a metal labda at 80 degrees as compared to when I'm bending it at 10 degrees. The most important parts katika bending operation are these 3 points, these contact points, hapo, hapo na hapo. Na pia kutegemea my punch ama the shape of my die, I can make my bend to be of cylindrical nature, or I can make my bend to be kama hii rectangular ama square bend. So that will be dependent on the type of the shape of my ram ama the shape of my punch. Now let me play a small video so that we can see how these machines look like katika workshop ama katika industry. Tumeona ambavyo hiyo bendi inafanyika. If you are with me, please unmute, sema present. Nisikuwa naongea peke yangu. Okay, so we have seen how that is done, sindio? Now we have another process known as cup drawing ama deep drawing. What this is, you will have a piece of workpiece ama chuma. You will place it on top of a die ambayo iko na cavity, a concave shape. Once you place it on top of that cavity, inashikiliwa ama it is held together. You have a cavity inakaa hivi, then you place your workpiece on top of it and then you clamp it. Then you will apply a force through a die ama a ram on top of that workpiece, and that workpiece will assume ama it will take the shape of that die. Sana sana this is used to make cups. Utaekelea chuma juu ya die ambayo iko na shimo, kisha unasukuma that workpiece into that hole. You're basically stretching that sheet of metal in certain areas so that inachukua the shape of that die. So let me just play a small video so that we can see how it is done, done kwa industry ama kwa workshop. As you can see, we have flat sheets of metal being pushed into these holes, and those sheets of metal take the shape of that hole. I think we have seen. Tumeona hapo. So that machine will push, itaskuma that sheet of metal, na hiyo chuma ama that material will take that shape of that hole, and that is called dip or cup drawing. Now we have another process ya metal sheet working ambayo inaitwa shearing. Shearing ni ile action ya kukata kama ukitumia makasi. That is the most common way I can explain. The scissors cut, and that is shearing. So you can do the same by putting a piece of metal on top of a die and applying a force on a punch ama a ram ama a die, and that metal will be torn ama itakatika through the shearing process. That is just a very simple explanation ya shearing, unakata chuma. Now all these processes ama any process in a workshop can be done using using cold working ama hot working. Now when I say mfano cold working, I mean that these processes are done below a temperature known as recrystallization temperature. Now this temperature is the temperature when you heat a piece of metal, just before that metal melts, before it melts, kuna temperature ambayo new crystals ama new particles ama new grains in that metal will be formed, and that temperature is known as recrystallization temperature. So when you're working on a metal below that temperature, below that temperature, let's say if I want to work on a piece of metal at room temperature, I've not heated that metal, that is known as cold working. If I'm going to forge nichukue chuma nigonge at room temperature, that is known as cold working, just below the recrystallization temperature. Now this type of processes that are done using cold working have advantages. One of those advantages is close tolerances can be achieved. That means that if I want to make my workpiece to be, let's say, I want to make a chair, and that chair dimension yake ni 10 centimeters by 10 centimeters, then it is easier for me to achieve 10 centimeters by 10 centimeters ama something close. My tolerance labda itakuwa plus or minus 1 or 2 centimeters. You will have a good surface finishing because you're not going to be doing anything on the surface. You're not heating it, you're not applying any chemicals, unagonga tu. You're just bending. So you're not doing anything to that metal. So that the surface of that metal will be finer. Itakuwa safi as compared to if I'm going to heat it hot working. We're going to see just a few what hot working is. Since I'm not going to be heating that metal, then my cost of electricity kwa ile workshop ama ile plant or the fuel will be less. So my cost will be lower as compared to someone who has to heat a piece of metal ama a piece of material. Machining requirements, kama na kunja chuma, all I will have to do is bend that metal. I won't have to cut the piece of metal, I won't have to polish it, I won't have to machine it. So my machining requirements are minimum. Now disadvantages. Once I heat, let's say I'm forging and I heat a piece of metal at below recrystallization temperature, itafika mahali my piece of metal itakuwa ngumu. I will change the internal structure of that piece of metal until it solidifies. I mean, it hardens. Then it will get to a point where no matter what force I apply, nothing will change. Unless now I use other machines, if I apply force beyond a certain level. So once I do, if I work on a piece of metal below recrystallization temperature, itakuwa ngumu. The internal structure will harden. And if that happens, then I will have to use higher forces to deform my material. Kama mtu ambaye anafanya ile kazi ya blacksmith, you see, unaona vile wanafanya kazi ngumu. Because you are requiring higher forces to deform that material, to change its shape. Especially now katika industrial level of machining ama industrial level of kule kwa industry. You will require heavier equipments, more powerful equipments to do the same work as compared to mtu ambaye ana heat his metal Someone who is increasing the temperature will require less force, less smaller machines as compared to ule mtu ambaye anafanya at room temperature. Some materials are not cannot be deformed at that temperature. You have to increase the temperature. Kuna materials ambazo ni ngumu. So despite how much utagonga, despite how much utabend, it will not be ductile. You had mentioned these properties of materials in one of the lessons we had met. So some workpieces or some metals cannot be changed. The shape cannot be changed, or it cannot be deformed at those temperatures. Now the opposite of cold working is hot working. You have to heat now the temperature above. You have to heat the metal, work on the metal above the recrystallization temperature. So we heat it, but we don't. It doesn't melt. It is just before the melting point. So this is the temperature at which now new crystals are being formed. Now you heat a metal, the internal structure changes, you get new particles, new crystals. Now the advantage, you will require less force. That's why you find people blacksmith wanaweka chuma katika moto, inakuwa moto ndio wanaanza kuigonga, because you will require less force. There is no limit to amount of hot working that I'm doing. What does this mean? If I'm going to be working, let's say I'm forging, natengeneza kiti, a metallic chair, and I'm making it and I'm not satisfied by the shape or the dimensions, I can continue hot working. I can heat it, work on it again, naichoma, work on it again, over and over again until I'm satisfied with my final product. So there's no limit to the number of times that you can continue hot working on a piece of material. Now the grain structure is refined because you are heating, you're working on that metal above the recrystallization temperature. You get that new materials, some new particles are being formed over and over again. You have new grains, you have new structures. So the material, the grain, the internal structure inakuwa finer. If you have impurities in your metal, your material, then they will be broken down. Zitakuwa redistributed around the metal, so they won't be found at one particular point. Zitakuwa redistributed all around the metal. So this reduces the weakness of a particular metal. Now, disadvantages. You have a very poor surface finish. Why? Once you heat a metal, you are exposing that metal, the surface, to the elements, the weather elements, some of the things around it. So it is susceptible, ama inakuwa more easy. It is easier for the mfano oxygen to react with that surface and form scales. Rusting. If you heat a metal and expose it to air, it will rust faster as compared to iron that has not been heated. So the surface is poor. Some metals, when you heat them, they become brittle. They can break easily. Kwa hivyo kuna chuma ambayo utaenda uta heat, ukigonga kidogo inavunjika, inakuwa kama glass. The same way in cold working, some metals cannot be bent ama cannot be worked on because they're not ductile enough. Some metals in hot working, once you heat them, they become brittle. They easily break. Dimensional accuracy. It's very difficult to achieve because you have to take into consideration the expansion and the contraction of that metal. So if I'm going to be making a material, let's say 10 centimeters by 10 centimeters, then I have to take into consideration that that metal will expand and it will contract once it cools down. So itakuwa ngumu sana kucheza na hizo the accuracy of those dimensions. Some metals, once you continually heat and heat a metal and then unaigonga ama you work on it, then the surface itachoka. As much as there is no limit to the amount of hot working that you can do, everything has kuna ile kikomo bana. So if you continually work on something over and over again, the surface, for lack of a better word, itachoka. So the layer, that surface layer, will crack because of continually working on it. Now, that was those processes ambazo tulitaja, we just say that they can be hot worked or they can be cold worked. Now, I want to introduce one process ambayo utapata sana sana katika industry, and this is casting. Casting is a very important process because when you are in the industry and let's say umeorder kitu ama kitu kimeharibika and you have been told that once you order something, let's say it's 1 million shillings, or it will take 1 year to come, you will have to make that material yourself. And sana sana these materials are made through the process of casting. So this is the process of, you have a cavity, a mold. A mold ni ile structure ambayo you make. We'll see some videos so that we can have a very rough idea. We can have an idea of what this process is. So you will take molten metal and you will pour it in a cavity, katika shimo. This hole, that cavity is usually made from a mold. Mfano, let's say I have a box. Box nikajaza mchanga. Then I will create a hole, a cavity in that sand, and then I will pour molten metal in that sand to take the shape of that hole. That is what we call casting. You pour molten metal into a cavity, you let it solidify. Once it solidifies, you break that mold, you break unabomoa whatever mold you have made, and then you get your final product. So that is what we call casting. Now, casting is a mfano kama engine. The most common material that we can see around that is cast is an engine block. It will be very difficult kuchukua chuma kisha ukaipeleka kwa industry ama kwa machine shop ukamwambia mtu nitengenezee engine. It is very difficult kwenda ukaanza kuchonga engine. No. What we do is we make a shape of an engine, kisha tukamwaga molten metal into that shape, and then once that engine block, that molten metal solidifies, then we can smoothen and we can work on it, and we'll have our engine block. Now, let me play a very casting can be permanent or it can be temporary. The permanent one, the difference is that mold ambayo unatengeneza, that cavity, the mold that you make your cavity with is permanent. It is made of metal. The temporary one, the sand cast, the inaitwa sand casting, we use sand, mchanga. We use sand to make that mold, and I want to play a very short clip so that you can have an idea of how sand casting is done. And if you've ever seen this process, let me know ili tuweze kushare with the class ili so that we can share. Now, before we endelea, I want us to unmute and say present so that I can know I'm with people. Naona watu wananiangalia, labda hata watu hawako na sisi. If you're with us, please unmute and say present. Is there any question up to that point? Now, if there is no question, then I'll play a very small clip so that we can see how sand casting, making final products from molten materials, how it is done. Tumeona kuna mtu ameipatana na hiyo procedure mahali ama hiyo process mahali? Now that process is what the things that you see on a day-to-day basis. That's how they are made. Engine block, valve, piston. That is how they are made. Now I will play that video again and then I will explain as they do it, what they are doing. Nitacheza hiyo video tena ili ni explain ni nini wanafanya, sawa sawa. Haya. Now what they are doing is that they are preparing these boxes mali ambapo wateka mchanga. This is a mold, the sand mold. This is now what is called sand casting. So what happens is you will place the thing that you want, the pattern of what you want to make. If I want to make an engine block, if I want to make a pencil, the pattern nitaweka katika hiyo mchanga. Kisha naeka mchanga and I press that sand so that it can be firm. You have to make sure that the sand unaweka it is firm, kwa sababu if you pour molten metal into that and it haijashikana vizuri, we'll have defects. I've given you an assignment to go look about the defects. So kutakuwa na shida katika ile casting. Now I don't know if you can see this. Anafinyilia huo mchanga. Kuna kitu ambacho alikuwa ameweka. This is known as a sprue. Ni pin ambayo unaweka katika ile mchanga so that you can have a place for that molten metal to go through. Now this thing ambayo ametoa hapa, that is your pattern. Whatever you want to make ndio hiyo hapa. Uliweka kwa mchanga, ukafinyilia mchanga so that ukatokea cavities ama shimo katika ile mchanga. So that when he returns that top box, sijui kama muli notice kuna box ya chini na kuna box ya juu. Ashatoa pattern, kwa hivyo kukabaki na cavities ama mashimo katika ile mchanga. Kwa hivyo akirudisha the top box, what will remain in that hiyo. Akisharudisha hii box ya juu, what has been left in the sand is holes ama cavities. So that when they go and pour now this molten metal, hii chuma ambayo wanachoma ikawa liquid, once they pour that molten metal into that opening, then that hii opening hapa, so that molten metal itaingia katika ile mchanga and it will take the shape of that cavity. Kwa hivyo wanamwaga hiyo chuma, the molten metal, into that sand, then once that metal solidifies, not cools, ikisha solidify wanavunja hiyo mold so that they can get their piece of metal ama ile casting ama that final product ambayo wanatengeneza, and then they dislodge the sand, wanavunja. Now kuna hizi yellow things ambazo ziko hapo ndani, those are known as cores, a core. So if I want to make a product ambayo iko na hollow ama iko na shimo katika ndani yake, I will place that core into my cavity so that once I pour the molten metal into that cavity, it will solidify around that core. Na nikivunja my mold ama nikitoa mchanga alafu nitoe my final product, I will just take out that core and the final product that I will have a hole. Itakuwa na shimo katikati yake. Now this is just a diagrammatic representation of that process. The things. Iko na hizi terms ambazo ni muhimu kuzijua. Now kuna ile cavity, mahali pattern, ukisheka pattern katika mchanga, ukaweka mchanga ukajaza, kisha ukatoa hizi boxes, you remove the pattern, and once you remove the pattern, what you're left with is a cavity, shimo katika ile mchanga. We have a cope, the bottom box inaitwa drag, and the top box is known as a cope. We have the mold, which is now the sand. Mold ni ile kama covering ama ile kitu ambayo unatumia kutengeneza your cavity. It's known as a mold. Now kuna pin ambayo alikuwa ameweka katika mchanga, and then after he has compressed the sand akaitoa so that you are left with a hole hapo katikati, and that is known as a down sprue. This is known as a down sprue. This is the passage ambayo will allow you to pour your molten metal into that mold so that iingie katika cavity. The same as the runner. The runner is just a place where the mold, this down sprue in the runner ni ile passage ambayo the molten metal will take so that it can go to the cavity. Now once it goes to the cavity, it will solidify ama itajaza cavity. Kisha jaza cavity, we have something known as a riser. A riser is what will help you know whether the cavity, will help you know whether the cavity imejaa. Kwa sababu you cannot see what is going on within the sand, you need something to help you know whether that cavity imejaa, whether the molten metal has filled the cavity. So we have something known as a riser. You can have it on this side, or you can have it on this other side of your mold. What it does is once the molten metal fills this cavity, itakuja ijaze hii riser. Sana sana hii riser inafika mpaka hapa juu. So that ikijaza cavity itakuja ijaze hii riser. So once you see that hii riser imejaa, then you can know that your mold, your molten metal has completely filled your cavity. So these are the common terms that you will see in sand casting. Now, let us look at the procedure that is followed while you are sand casting, kwa sababu huwezi enda tu ukaanza ukajaza mchanga katika box. So let us look at the process of sand casting. Are there any questions? Are there any questions up to that point? Now, if you are together, please unmute and say present. Present. Naona kuna watu ambao labda wamezima video na wakamute na mtu labda ako shughuli zake. So if you are with us, unmute, sema present ili tuendelee. Yes.
Hiyo video unaonyesha hapo, the letters iko very small.
What I'll do is I'm still preparing this presentation. So once I am done, I will send it kwa ile Google Classroom, because these videos I can't send them katika WhatsApp, they're too big. But what you can do in the meantime ni unaweza enda tu YouTube ukatafuta hiyo process, utaipata tu iko hapo.
Sawa. That maybe video sauti kidogo unaweza saidia kama unaongeza kiasi.
Okay. Haya, thank you for letting me know. Kama kuna shida nyingine pia niambieni ili nisikuwe nafunza na na msikii chochote ama muoni chochote. Okay. Now, the advantages of sand casting ni mfano ni kama if I'm going to like it's very possible to make complex shapes. Kama mfano engine block. An engine block is a very complex shape. Unaweza imagine ukienda kuenda kuchonga engine, it will be very difficult. So you can make very complex shapes by sand casting. It is also possible to cast metals ambazo ni ferrous and non-ferrous. Unajua sana sana we will see why we will see in a few the biggest disadvantage of permanent mold casting. But it is in sand casting it is possible to cast ferrous and non-ferrous materials, even non-metals. It is very possible to cast non-metals. Now, the tools ambazo tumeona hapo are very inexpensive. They are very common tools. A shovel. Kuna ile box. You can even have wooden boxes ama cast iron boxes. They are not expensive. So the tools they use are very cheap and they are very simple. Now, the size and limitation, size and weight of a product. Sio shida. I can cast something as big as an engine, hata ya meli, which is, let's say, 5,000, 10,000 kilograms. And I can cast a simple thing kama penseli. So the size and the weight of a material, sio shida. It will just depend on the size of your pattern. Ile pattern ndio ile shape ambayo unataka ile mold ikuwe nayo. So if I want to make an engine, it is very possible. If I want to cast up a pen, it is very possible. Now, disadvantage ya sand casting is that the accuracy and the surface finishing is dependent on the work you do. Craftsmanship. If you do a very poor job katika labda ile kubonda ile mchanga, then the casting ama the final product will be poor. Especially that ramming, the compressing of the sand, it is very important. One of the biggest mistakes people make when they're doing this process ni kutofinyilia ule mchanga. So what happens when you pour molten metal into that mold is that sand in a break. That mold breaks. And then the casting itatokea ikiwa mbaya. And that is one of the defects that you will see once you do that assignment. The surface will be rough. So if your ile pattern ambayo uneka katika ile mchanga ilitengenezwa vibaya, then the casting that will come out will also be rough. Sand itself is rough. So the surface will be poor. So you'll have to work on the surface so that you can get a final product. It is also labor intensive. It requires a lot of time and work. We saw that in the first video, ile video wakiweka mchanga, wana compress mchanga, it takes a lot of time. Katika kwanza ile kufinyilia ule mchanga, if you're going to be doing it manually, utachoka. So hiyo ni kazi ambayo lazima ukuwe umekula vizuri. Now, some of the tools that we use in sand casting are listed below, but I'll go through them one by even showing you a diagram. We already are familiar with the shovel. Hii tumeona, hii najua tushaona. So this is what you'll be using to load sand into those boxes. We have trowels. Once you put the sand into the boxes, we'll use these trowels to level the sand, to fix it iwe flat. Ni kama ile tu ya watu wa mjengo na watu wa masonry. Wakishaweka cement katika ukuta, they will use it to level that mixture ya mchanga so that it can have a good surface. We have a lifter. Now, in those holes ambazo utatengeneza katika your sand mold, mchanga inaweza bomoka ikaingia katika hayo mashimo. So we'll use a lifter to fix those holes. If there is sand in that hole, you use a lifter to remove it. So you use a lifter to fix any problems in holes. A strike-off bar. Now, once you've filled your boxes with sand, I will pass a strike-off bar on top of my box so that it will remove any excess sand that I do not require. Unatumia a strike-off bar to remove the excess sand in those boxes. The top box, which is the cup, and the bottom box, which is known as a drag. Na riddle ni kichungi tu. You see that process ya kuweka mchanga katika hizo boxes. The first few za mchanga ambazo unaweka can be rough, but once ukienda kujaza box, you use a riddle ama kichungi so that you can filter out the sand. You won't find particles, so that when ile mchanga ambayo inajaza the top part of the box is fine. You use that so that you can filter out, utoe yale mabonde ya mchanga ambayo ni makubwa, so that the sand that falls into the box is fine. So that when you're compressing that sand in those boxes, the process itself sio ngumu. Kama uko na mabonde ya sand katika hiyo box, it will take much time to break them and to compress that fine ile iwe tight. So riddle ni kichungi that you use to filter the sand. Now, something that they did not show katika hizo videos is a venting. Kutengeneza, you use something known as a vent wire. A vent wire is very important because you need to provide a passage for the escape of the gases, the hot gases from the molten metal. Lazima upatie njia for those gases to escape from that mold. Because if you don't do that, those gases will expand in the mold. And what happens when they expand in that mold? They will break it. The mold will itaanza kuvunjika. That means that your mold, your casting ambayo that solid, once that metal, the molten metal solidifies, itakuwa na shida. It will have defects. So once you're doing that assignment, look at the defects that are formed once you don't vent the sand. That's that mold. Now we have rammers. These are what you use to compress that sand in those boxes. In the industries, you might find that this ramming process is done by a machine, by a hydraulic machine. Lakini kama unafanya hii process kwa mtaa, you will use rammers, mkono. Ni kama ile kisiagi ya maize, ile ambayo unachukua unagonga. It is the same thing. It looks similar. Kuna ile hizi hapa, so you'll use them to compress the sand in the boxes. Now this is a sprue cutter. This is inaitwa sprue pin ama sprue cutter. This, I don't know if you saw it katika ile video ya kwanza. It is what you will use to provide a passageway for the molten metal to enter. Unaweza weka katika ile box kisha ukaweka mchanga around it. So once you compress the sand, unaitoa. Once you remove it, you will be left with a passage for the molten metal to pass through it. So it is known as a sprue cutter or a sprue pin. And there's so many other tools that you will find in sand casting. I've just mentioned a few that are common. Now, permanent mold casting, the difference in sand casting is that the mold will not be used in sand anymore. The mold will be made of metal, kama steel or cast iron or aluminium, kutegemea na which casting that you're doing. So this mold is machined, imechongwa na machine, ikatengenezwa. So the pattern, you will not be inserting a pattern into that permanent cast. No, the pattern itself is made in the mold. So what you'll do is you'll have a mold ya chuma with pattern. Pattern yake ishakuwa imechongwa katika ile mold. Unafunika ile mold hizo mbili. Kisha utakuwa na cavity ndani. You have a pattern on this mold, you have a pattern on this mold. Once you bring them together, you will have a cavity inside the mold. So when you pour the molten metal into that cavity, then you will have a casting. So the difference between sand casting and permanent is that in sand casting the mold is made of sand, and in permanent the mold is permanent in chuma. So we can reuse that mold over and over again until lifespan yake ifike, until it wears out. So that is permanent mold casting. Now I'll give you a homework ya leo tu, ile tu uende ufanye research kidogo. I want you to go find, I will even post it katika Google Classroom, so that you can at least have refer. Go and find out what type of sand is used in sand casting. Kwa sababu siwezi enda kwa beach nikachukua mchanga kisha nikakuja nikatengeneza mold. That type of sand will break easily. So there is a very special type of sand that is used to do sand casting. Now the steps that we have to take in permanent mold casting is the mold, kwa sababu ni permanent, you have to preheat it. You have to ensure that it can accommodate the flow of the molten metal katikati ndani yake. So you preheat it and you apply a coating kama lubricant. So if within ama inside that permanent casting, itakuwa moto na kisha una apply lubricant, so that once you pour the molten metal into that casting, it will flow easily into the cavity. Ukishafanya hiyo process, funika ama funga hiyo ya casting. Once you close that casting, then that is when the cavity will be formed. Ndio maana hapo ndio utaona ile shape ambayo unataka kutengeneza. Once you close the molds, then you can pour the molten metal into that mold. Once the mold solidifies, then you'll open once the casting solidifies, you can now open the molds, and then you'll have a final finished product. Any question up to that point? Always.
What's the difference in use between the sand casting and
sasa kama sand casting, it is done when you're dealing with labda huge things kama engine ambayo mfano uko na gari, engine imeharibika, ukaambiwa kutengeneza engine kununua engine mpya ni 10 million. You know, if you can't labda wewe kama uwezi afford, the other option is you make it yourself. So sand casting is used to make complex things that cannot be easily be found kama valves, engines, and ni one of sio ya kila siku. Uhitaji kununua kutengeneza engine kila siku, so you will use it in temporary. It depends with the demand. Lakini permanent hii sana inatumika kwa industry for batch production. If you're producing things in bulk kama toys za watoto, let's say an industry is producing 1000 toys per day, you cannot do that with sand casting kwa sababu you'll have to be making sand molds kila siku kama kila wakati unatengeneza mold ya mchanga, unavunja, unatengeneza nyingine, unavunja, so that will take time. So the permanent one unachonga mold ambayo inafanana na ile toy, so you can pour molten metal into it. It's reusable. Your permanent ni reusable. Sijui kama unanielewa. Okay. So we use sana hii permanent in industrial applications. If you're going to be making something over and over again, easy toys, pencils, things that can be made in batches, we use permanent. But for sand is one off. If I'm going to make an engine block layer, I won't be making another one tomorrow. I won't need another one tomorrow. Inategemea na demand. Now this is just a diagrammatic representation of that process of permanent mold casting. You will open your mold, preheat it, and spray a lubricant to ensure that the molten metal can flow easily into the cavity. Once you've done that, you close. Sana you'll find that katika hii permanent, one of the mold is movable and the other mold is permanent, is fixed. So you close them. Once you close them, that is when you'll find the shape ama kutakuwa na cavity formed. If I want to make a casting ambayo iko na a hole ama iko na hollow section, then I will insert a core so that once the molten metal comes and it solidifies, it will solidify around that core. Kisha unamwaga your molten metal into that cavity, you then open that cavity, and then you'll have your casting exposed. You'll now get your final product. Now advantages ya permanent mold casting is that the surface will be better as compared kwa ile ya sand casting. You can even imagine surface ya mchanga na surface ya chuma ni gani ambayo itatokea ikiwa smoother. For the permanent one, it will assume that shape of that casting ya chuma, so it will have a better surface. It is also better, the accuracy of the dimensions is better as compared to ile ya sand casting. If my permanent mold has been constructed in such a way that I'm getting a casting which is 10 centimeters by 10 centimeters, then my final product will be closer to 10 centimeters by 10 centimeters. Reason being, that casting doesn't change its shape. It will remain the same as compared to ile ya sand casting. The level of accuracy in my sand casting will be dependent on how well I do that job. If I'm very poor nitaifanya na haraka, then my casting ama my final product will be of poor quality. Then finer grain structure, because my casting doesn't change its shape, then once that molten metal solidifies, and once it assumes that shape of that casting, it assumes the shape of that mold, since the mold will not change its shape, if I'm going to be making a casting of 10 centimeters by 10 centimeters, that is what I will get as my final product. So that means that the structure, the grains in that mold, in that casting will be fine as compared to ile sand casting. The level of fineness of my grains will be dependent on how well I do my job. If I do a very good job, then my casting will be perfect. If not, itakuwa mbaya. For that reason, the castings that are produced in permanent mold casting are of better quality, are of better standards as compared to those of sand casting, so they are therefore stronger. Are we together? Now, disadvantages. The major disadvantage is that we cannot cast a metal that is of a higher melting point than the mold itself. Mfano, if my mold is made of steel and the melting point of steel is let's say 1000 degrees Celsius, siwezi enda nikachukua chuma ambayo its melting point is 3000 degrees Celsius and then I pour it into a mold of steel whose melting point is let's say 1000. Once I do that, my mold itamelt ama itaharibiwa. So it is limited to metals that have a lower melting point than the mold. Also the mold is expensive. Kuchonga hiyo mold ili ikuwe na hiyo shape ya pattern ambayo unataka kutengeneza, it is very expensive. That's why it is limited to very simple parts. Kama natengeneza toy, that is all I can make. I cannot go and make a mold ambayo inaweza tengeneza an engine. You can imagine making a shape of an engine kwa mold. It will be very expensive. So it is only limited to simple parts. I cannot make complex patterns using permanent mold casting. Now this is just a picture that shows common defects katika castings, and I've given you that as an assignment, so I will not talk about it now. Go and look at diagrams, andika kitu kidogo, show me the representation using diagrams, and then you submit it as indicated katika ile Google Classroom. So read and find out how these defects come about, what causes them, and even use diagrams to indicate. Now, if you are together, please unmute, let's say present. Thank you, Daniel.
Present.
Asante sana Neshim. Dorothy, tuko pamoja?
Yes.
Stevie ndio nashangaa mbona aongee bana amelogin kwa class. But now let's continue. Now once you're done with the process of casting, you have to ensure that the product that you get is ni safi. I think you saw katika ile video ya sand casting. Once they finish that process, walikuwa wanachukua ile casting wanagonga na nyundo ama wanaangusha na vunja. Because that process itself, you'll find that you have unwanted materials. Let me go back to this diagram so that you can see what I mean. Yep. Once you pour your molten metal into that cavity, the final product, the product I want is this shape. But your molten metal itakuja ijaza hii, saa zingine itakuja mpaka ikajaza hii sprue. So all this is unwanted. So we have to remove it. We have to clean that casting so that the product that we get at the end is what we need. And the process of cleaning can be kuna rough cleaning. The removal of those gates, your gate and risers. Rough, unachukua nyundo unagonga inavunjika, ama unaweza chukua casting yako yenyewe ukaichukua ukaangusha ikavunjika. Surface cleaning. For that process of casting, that will have things attaching themselves on the casting, the sand, the coatings, zitastick katika ile casting yako, so you'll have to clean that surface. We can use a wire brush. We can use grinders to remove those materials. You have trimming. Kuna zile unwanted edges that we do not require. You can use a file. You can use a chisel. A grinder pia unaweza itumia. Once you are satisfied that you have cleaned enough, then you can have finishing processes. The processes we had talked about in one of our classes: polishing, buffing, electroplating. Depending on the type of the reason why you are casting, then you can perform finishing processes and decorative processes on the final product. Now let me show you a video of mtu ambaye amefanya casting na anataka kusafisha casting yake.
This morning we're going to be cleaning up the casting that we made last night. So I'm going to start by cutting the sprue off.
So this is a place where he poured the molten metal. So you have to remove that part.
Okay, so yeah, I ground those off with the grinder. It was a lot easier. Alright, so go ahead and reseat this guy again. Check it for true. Alright. There's the start.
Now, for those who have never seen a lathe machine, this is what we call a lathe machine. We have a workpiece being inashikwa na clamp, inakuwa tightened, and then you have a cutting tool ambao unatumia kukata ama use it for machining processes. I don't know if you can remember katika ile workshop safety rules nilikuwa naambia msivae loose clothing kwa sababu hiyo loose clothing inaweza shikwa na hii ikakuvuta ndani ukaumia. So this is what is called a lathe machine. We will look at it in the next topic when we talk about workshop tools.
Alright, YouTube, here's the pattern. And here's the casting cleaned up with the screws cut off. Here we go. Let's look here. I'm gonna clean it.
So this is his pattern and this is his casting. So this is the pattern ambayo uteka katika mchanga. Ukishatoa hii pattern unabaki na cavity. Once you remain in the cavity, utamwaga molten metal and this is what you get. But once you get this, you have to clean it. You can see the surface finish in your sand casting is very poor. So that is just a video that shows how cleaning of casting can be done. Is there any question? Any question? Now, once you are done with the casting process, you have to ensure that the materials that you get ama the final product that you get is of standard. It can be able to withstand the job ambayo unatengenezea. Kama natengeneza ama if I'm casting mfano suspension ya gari, I have to ensure that it can be able to handle the weight and the forces in that car. So one of the testing methods ni non-destructive. They're usually categorized in two major ways: non-destructive and destructive. Non-destructive, I'm not going to destroy the casting. Mfano ni kama X-ray, the radiographic inspection. I will take my casting, I will send it to a laboratory, ipigwe X-ray, and then we can be able to see the internal structure. If there are internal cracks, we will be able to see. If there are internal stresses, we can be able to see. Another common one is fluorescent ama dye penetration. What you do is you take a dye, a colored liquid, you apply it on the surface of your casting, and then you wipe it off. Kama kuna mashimo na mabonde katika your casting, the dye will remain in those holes, in those cracks, and then you can be able to see that there are defects. If there are none, if I wipe off that dye, itatoka tu yote. So those are common non-destructive methods. Destructive methods are just as how they sound. Unapeleka your casting into a laboratory, it is tested, inavunjwa, so that you can know at what strength, its durability, its strength. At what force will that casting break? At what force will it, ukivuta, at what point, at what pressure will it break? So that is the inspection of castings, the most common methods. Now for today we'll reach there.